Hello guys, welcome to learning microcontrollers. In this video I will show you what is embedded systems. Now embedded systems have a great thing to do with the microcontrollers. That's why what I will tell you here, what is the embedded system? It will define the scope of the microcontrollers. So let's get started. So guys, this is an ordinary computer. You are familiar with this, and it is easily available in the market. We even all of us have it in our homes. Today it might have been replaced with a laptop, but still it's a computer. It's in use, and it is available in the labs and everywhere in the world. And its cost is like minimum you can buy a low cost PC up to like $500 or even cheaper as well, like Pentium 3, Pentium 4, etc. But they are powerful computers. Now the next thing is, this is a tower type CPU. Now you can see that this is a whole computer with the peripheral devices. Keyboard is a peripheral device, mouse is a peripheral device, this LCD is a peripheral device. So it's an output device, the LCD. This is the CPU. It has the motherboard, hard disk, CD-ROM, USB ports, etc. And this has the microprocessor, which is the brain of the computer as well. So this is the CPU, this whole tower type casing. Now this is the CPU in our term. Basically it's a tower type casing having the motherboard, power supply, DVD-ROM, storage devices, etc. inside it. So you can see the tower type CPU, only this CPU cost around less, or minimum you can buy a cheapest around like $200. You can also have less than that with like Pentium 3, 4, etc. or dual core type PCs, but it's around like $200 nowadays. Now the next thing is, this is the same in desktop format. Now I'm trying to make it compact. Like we want to make a drone, so we cannot like connect this on the drone to do the programming and to do the processing because it's too big. Now this is somewhat smaller. This is the desktop type CPU. Now it's a desktop type, same CPU having a bit smaller motherboard, smaller power supply, smaller DVD-ROM, smaller floppy drive, smaller all other devices, so it can be more compact. You can see that it's a bit more compact, and it's also the same cost around $200 nowadays. And now this guys is the compact, the micro tower type CPU you can buy in the market. It's very small. You can see that it's like having two USB ports, but it is very small. You can use it in various applications. Like if you want to make a washing machine, you can like embed this into it, like you can connect it into it, and it will become the part of that machine. This can be done, but the problem is it is very expensive. Like these small computers nowadays are good quality computers are costing up to $1,000, or the cheapest you can get some used in the market which works or not, I don't know, that will be like $500, $600, or some low end you can still buy new at $700 to $800, which is a lot of cost. Suppose you are buying a washing machine with some computer inside it with special features like Wi-Fi, etc. And if this thing costs around $500 to $600, then the machine cost is like doubled or tripled. So no one is going to buy that. So now this is compact, but this is expensive. Even compact than this is a USB PC, but they are more expensive. Now so this is also useless in our applications. Now guys, this is a laptop type computer that nowadays they have also become very slim and smart. Still it comes with an LCD. Like you want to install this onto a washing machine, or you are making a drone, you cannot install this on that because this LCD will be wasted. We only want the limited functionality, like we just want the microprocessor to do the processing, some memory, some RAM, some small amount of features which will do the required processings. So this is a around $500 you can buy a good laptop nowadays, and you can go for the previous generations as well, less than that, but they are heavy and bulky. But $500 is the mediocre range for the used laptop. Now guys, what I am trying to bring you to is that, suppose now we want to make a quadcopter control system. So this is our chassis, we want to make a control on it. Now we will remove all the electronic and we want our own electronics. Now guys, the problem is that, what's the problem? Now we want a computer inside it. Like we want a computer which will be able to do the programming, like we will be able to do the programming to it, and then it will control these motors and to the speed of these motors using the motor drivers. So that will be the basic functionality. Then there will be a radio frequency module which will be connected, and we will control it using our mobile phone, or we will make a remote, etc. But the problem is we need a computer here which will do the required processing. Now the cost of this drone is around like $1,000. So people cannot buy this above $1,000. That's a huge cost. Now if we go with this one, a laptop, It's too big, it will not fit on it. You can see that where we will fit it. It's too big. Now if we go with this micro tower type CPU, now remember the budget is $1,000. If $1,000 is for the whole drone and we just add this micro tower for the $1,000, then it's too expensive. No one is going to buy it. Now if we go for the USB type, that is even more expensive, will not serve our purpose. Now this is too big, this is also big, and this is the complete setup, and this is totally illogical. They might be cheap, this might be cheap, but it is big. It cannot fit into it. Like even if you take the motherboard out, still it's big. Motherboard is also big. So what is the solution? Now the solution, the problem is that we may use the analog ICs. We use the digital logic design to make a control using AND or NOR gate, but the board becomes too big, and that's a very difficult task to make such a design. It takes a lot of hard work. A beginner cannot do it. You will need a sort of electronics engineer degree and then the experience in the field, and that will also become costly, because the person who is capable to design such a board, make it work, will not be a cheap engineer. He will take a lot of fee. So this is also not a very feasible solution for a beginner. I want to make this control of this drone with minimum knowledge and minimum expenditure on my education as well. So that is also not possible at cheap cost. So now we cannot use a tower type, desktop type, laptop type system. They are too big, although they can do the job, but where we are going to fit it? While the micro tower type computers are too expensive, they even go above the cost of this drone. Now then, what is the solution? The solution depends upon the type of controller. Now first we see what type of controller do we want. Now number one, it should be lightweight, that it should be installed on the system. It becomes a part of the system, or it becomes an embedded system with that computer. Number two, that must be reprogrammable. We will do the programming, like whatever the programming we want to do to it. Like this should, that when the forward is pressed, these two rotors will increase the speed, these rotors will decrease the speed, and it will go forward. Now if we want to go reverse, then these two rotors will increase. This programming, this type of logic development. Like we don't want to use a digital analog ICs like AND gate, OR gate, NOR gate, digital ICs or operational amplifiers or such things. We don't want to use a DLD, digital logic design, or analog ICs, because that's too difficult to design and implement that system and requires a lot of space, and we don't have that much knowledge or that much degrees and that much experience in that field. So we want a programmable system. We will just write a C++ code and burn into it. So it must be programmable. Now the third is that should have all spec of a PC, like it should have the RAM, it should have the ROM, it should have a microprocessor, it should have peripheral devices, like the motor in our case, like in a computer a mouse is and a keyboard is a peripheral devices. Here the motors are the peripheral devices, this camera is a peripheral device, the radio frequency module is a peripheral device. Whatever the devices we have should be interfaceable using various ports like UART, I2C or SPI, whatever we have. Now these are our requirements. Now what thing can fulfill these requirements? Now storage is also required, a ROM, a memory which will store the EEPROM, erasable programmable EEPROM, which will store the code and we can reprogram it as well. So these requirements, like a PC can do all that, but the PCs are too big. Then we need a small computer which is too small that it will even fit on the small PCB board. That is what we need here. So now this is a solution. Now this is a microcontroller. You can see that it's a PIC16F877A, and microcontroller is not PIC. There is Microchip making PIC microcontrollers. We have Atmel making 80 megacontrollers, the AVR series. We have Raspberry Pi Pico, it's a beautiful microcontroller. We have Cortex series, we have STM32 in the market, which are now flooded the market. We have Node MCUs, we have ESP32 MCU. All of these companies are making tons of microcontrollers, and they are easily available in the market. These microcontrollers are basically computers. They are small computers, small embedded computer. A microcontroller is a lightweight IC. It is, even this is heavy, it's a DIP version. It is also available in the SMD version as well. SMD is even smaller and more lighter than this. The same IC you can also buy in the SMD package as well. So it depends upon the package. It's already light enough that it can do the job. We can install it on our quadcopter to run the motors and other stuff. Now the lightweight, this spec is checked. It is reprogrammable. You can use a Picket 3 to program it. Like in case of Atmel or Arduino you can use a cable. Raspberry Pi also uses a normal mobile cable. Cortex series also uses a programming device, a burner. STM32 uses normal PC cable, mobile cable. Node MCU also uses same cable. ESP32 also uses the same cable that you connect with your mobile phone. So these all the systems can be programmed in a cheap possible way. Now they are cheap, easily available in the market, and cheap PIC is also available. Atmel, Arduino, all are easily available. Raspberry Pi is available, Cortex is available, STM32. These embedded computers, small computers, are easily available in the market. They have built-in RAM. Each have its own RAM. You can check the specification for the datasheet. Datasheet for the specifications. And they have their built-in ROM. They have storage space. That depends how much programming you want to do. So they are easily available in the market, and they can run our quadcopter. Now for the peripheral devices, they have certain ports. Like for the PIC16FA777A, I have a video like introduction to PIC. I will share the link in the description. This microcontroller has SPI port, UART port, GPIO pins, ADC ports. You can use any of those pins and ports depending upon the interface required, like PWM pins as well, to drive your motor drivers. So they can run the peripherals. Now what I want to show you is that what is the meaning of the word embedded. I have just taken it from the Wikipedia. You can check the dictionaries as well. So what the word embedded means, it means that fixed firmly and deeply in a surrounding mass, implanted. A gold ring with 9 embedded stones. See, embedded means something which is fit into the system. Now it becomes a part of the system. Something which was not the part of the system, but you have installed it. Now it has become part of the system. A gold ring with 9 embedded stones. See, a ring with a stone. Stone, once installed in the ring, it becomes the part of the ring. Now you don't call it that this is a ring with a stone. You simply call it it's a ring. And what is the stone? That's an emerald or something like that. See, the stone has become the part of the ring. That is called the embedded system. Now here you can see that this microcontroller, once it has been installed in your quadcopter, then you don't no longer call it that it's a small microcomputer having its own RAM and ROM installed on the chassis of a quadcopter. You simply call it it's a quadcopter. It has a built-in computer, and that computer is this microcontroller. So this microcontroller is basically an embedded computer once it's embedded into the system. Now suppose you want to buy a washing machine. Now for the washing machine, this microcontroller is few dollars, like $5 to $10, easily available in the market. Now this is very feasible. You can just convert a ordinary $100 washing machine by using this microcontroller, by adding additional features into a $1,000 micro machine. While your cost is simple, the programming, you simply programmed in some creative way. All you need is creativity now. You are no longer worried by the space, by the cost of the system. You have the system. Now all you need is to invest your time in learning programming. That's all. Now this is the definition of the embedded system in our perspective, like in the perspective of the microcontroller. I didn't do much research because I know the definition. Now I had also made it clear to you. You will also know the definition. Now see, on this chip here you can see these black chips. They are other packages, like you have the microcontroller in DIP package, SMD package. I will show you on the Google. Okay, now see what it says. An embedded system is a computer system. See, a combination of a computer processor, computer memory, input output peripheral devices that has a dedicated function within a larger mechanical or electronic system. Now see, dedicated word, highlight this, that it has a dedicated purpose. Like in a washing machine, the purpose of the embedded system is simply to just run the machine. It no longer is acting as a normal computer. You will not be playing PC games on a washing machine. You will not be installing Windows on a washing machine. So you don't need that amount of specs anymore. All you need is a computer, small computer, which will allow you to like trigger buttons, hold the timers, connect a Wi-Fi module. That's all. And that can be done with a small chip like PIC16FA777A, like you can see a chip here. So that PIC microcontroller is a small computer you just installed into the machine. Now it has become an embedded system. That machine is an embedded system because it has an embedded computer called microcontroller, and that is a PIC or whatever the company you chose. See, it's simple as that. Now how I define the micro embedded system in my own words, you can just look for other definitions. So an embedded system is a system in which an embedded computer like a microcontroller is used to perform the task of a computer with limited functionality, which reduces the cost of the system, and it becomes the part of the machine or we can say that it gets embedded into the machine, making an embedded system. Like a stone is embedded into the ring, making a ring. We don't call that this is a ring embedded with a stone. We call that it's a ring. What stone? It has a diamond on it. So simple as that. Now the computer, a small microcomputer called microcontroller, is embedded into a washing machine or a drone or whatever device, like a 3D printer or whatever device you have in CNC machine. Or there are a number of devices like your power supplies or your mobile phone or your various other devices you find everywhere in your room, like hair dryers, like your computer mouse. Even it's an embedded system, have a small microcontroller. TV remote as well, they also have microcontrollers. Every device that you found near you have a small microchip called microcontroller installed on its PCB. So that's an embedded system. Why? Because it has a small computer embedded on it. Okay, now I will go to the Google to give you some more examples. Now let me turn on the magnifier so you guys can see better. Now guys, take a look here. Now what I show you is that, see, these are all embedded systems. Now you can see that it is showing a microcontroller. Now see, this over here is a chip. Let me show you SMD PIC16 F877A. Now this is the SMD form of PIC16 F877A. It is more lighter, easy to be connected. See, it is very small that it can even sit on the piece of a coin. See, it is so small, so compact. Like it has a built-in RAM, ROM, and ability to connect peripheral devices like motors, other sensors, modules, etc. using its ports. But it's very small. Now it's a small computer which can be embedded anywhere. Now I show you the same PIC in a DIP package. Now DIP PIC16 F877A. See, now this is a DIP one. See, it's a bit bigger, but it is easy for the learner purpose. But if it is doing your job, you can just use this. This is easy to solder, easy to program. It has a easy base, like it can be installed on the base as well. Now these are embedded system. Now you go for other companies. I write here Arduino or Uno. Now see, this is another embedded system. You can see that on this there is a microcontroller called ATmega 328P. This is an Atmel ATmega 328P. Rest is just a board. Now you can see that this is a microcontroller. And now I show you that ATmega 328P DIP. Now this is the same embedded computer, small microcontroller having a DIP form. See, it's a DIP form. Now I show you same in the SMD. I write here ATmega 328P SMD package. Now see, this is the same microcontroller in the SMD. It is even more compact. Both do the same job. Now if you go to the data sheet of a PIC16 F877A or just the specs, you will find that it shows that, see, it have ADC port which will connect the peripheral devices like sensors. It has built-in RAM of 368, program memory size like the storage. It has low power ADC channel, and you can see various other features that it has. Let me show you. See, now there you can see it has 2 PWM, 256 byte of programming, data memory storage. It has ICD, self-programming, parallel slave port, and here you can see more parameters like ADC ports. This will be used to connect the peripheral devices, comparators, additional functions, data. This is the storage that we have in the PC, like we have a hard disk. It's a small PC. Power requirement, it's a small PC, just works on 5.5 volt, a small battery or a small power source. Unlike if you install your complete PC into a washing machine, that will require 220 volt, or in some countries it will be 110 volts. Of the source. So this is compact, it just requires 5 volt to operate. You can see it has its RAM, it has its ROM and program memory, storage memory, and it has certain amounts of pins so you can connect the peripheral devices, and it has like everything that a computer has. So it's a small computer, so simple as that. Now let me show you the card of a fridge PCB card, like a normal fridge you have in your house. You can see that on all of these cards you will find this type of chips. See, this is a microcontroller. You can see that this over here is the microcontroller. So this is called an embedded computer. See, now it is embedded into your fridge. You don't know that it's embedded. Now it has certain peripherals which will be controlled by these jacks like motor, switches like sensor which will calculate the temperature or other stuff. Then you have the power electronics as well working in parallel. See, these are the fridge cards. I show you the AC card, split AC card, PCB card. See, you will look into it as well. Now here you can see the chip as well. See this chip, this is some sort of, you can see that this one has better clear chip. Now this has a microcontroller here. You can see that it's a chip, black color chip. It's a microcontroller embedded into this system. So it's an embedded system. We don't call it like it's an AC having a small computer in it. We call it just a AC having an embedded system which is running it. So this is the embedded system, is a field of electrical engineering where you use the microcontrollers to run these PCB cards or make a control for them. So this is a very powerful field nowadays. So that's what an embedded system is all about. So I hope you guys learned something from this video. If you guys have any questions, you can ask me in the comment. So guys, we'll see you in the next video. Goodbye until then.